Okay. Hello there. See, where is this? Uruguay. Uruguay, guys. Very cool. Laguna Grazan Bridge. Garzon. Okay. All right. See. Easy one. Hmm. Counting bit. Maslow in the morning. Okay, so 2. We gotta give 0 is 0, 0, 0, 0. 1 is 0, 0, 0, 1. 2 is 0, 0, 0. Trying to see if you can figure out the pattern. Okay, so 1, 1, right? 4 is 0, 100. Does look like let's just keep going. 5 is so 2 is like a 0 after 1 bit. This one, this. And 3 is this one. So can we gain any information from the previous bit that we did? Just keep going. Trying to see the pattern here. And then 8. So 0, we will see 0. 1, we see 1. So that's kind of like the base case. So how do we infer 2 from 1? Number 1 bit from 1. So 2 gonna be 1 plus 1, right? No. Because we don't want to rerun these again for every bit, right? Every number. We want to somehow figure out the strategy, the result based on previous numbers. Okay. So it look like for 3, right, it's gonna be equal to 2 plus 1. So we know the number of 1 in 2, we got 1. Number 1 here, it's gonna be it'll be 2, right? Okay. So we can say here is 2 plus 1, which is 2 had one number, 1 bit. Number 1 is 1, this is 1, equal 2, right? So maybe odd number, that's the one. It's gonna be three. Got 2 here. Because 2, right? How many 1 into 1? But this should be 3? No, but it's actually no. This hypothesis is wrong. It's 2. So if we split a number into 2 components, that's actually still wrong. But at least we know this is 0, this is 1. So how do we figure out 2? We choose like a base case where it's also 1. But at least we know 3, the number of 2 bit here. Right. So if we can find out so based on previous number, this is not correct though. So like for example, if we do what, 3, 4, or is it 3? is 2 plus 1. This is 1. This is 3, no. Or is it 2 plus 2, right? 2. 2 plus 2 is 1 plus 2. Is 2? No. Still wrong. So, gotta figure out a different way. So the one go here, and then the one here up. Right? So it looks like the one here just keep going. Let me keep thinking. So we know at least it seems like every 2 to the I number, right? The position that I will be 1 and everything else is 0, right? So because this is 2, we don't count this. This is 2 to the 0. Okay. So the 0 position is 1. Okay, this is 2 to the 1. Right? Well, let's sketch all the. This one is wrong. Right. So let's get all this out of the way first. So we know 2 to the 2 here. That means 0, 1, 2. So this will be 1 for sure, right? So this is 1 because of 2 to the 2. And this is 2 to the 8. 2 to the 3, sorry. And it's just have 1. Right? Okay. So between these, when we need to figure out. Okay. So for these number, how do we know? So it definitely have 1 for sure. It's gonna be okay. Is it b minus? Okay, so this is okay. So how will we figure out 5 here? 5 is 2, right? So definitely have 1 because it's greater than the map to the 2. Okay. How do we get the other one? So this one is we expecting 2, and this one we also have 2. Right, this one is 3. Right. So all of these, because it is because it's greater than 2 to 2, it has 1 bit for sure. And how many bit does it have? Depending on 2 to 2 here for sure. Okay. So for 5 here, 2 to 2 to 4 here, does that mean this is actually 4, right? So this is actually, oh no, this is 8. This is 1 again. So this has 1 bit. This has, what's the pattern here? And so on. With this 3 here for sure had 1 bit. That's 2 to the 1. Right. So we need to somehow get 2. Right. With water. Okay, what we need to find out. So how do we figure out how many bits do we need, right? Because it seems like from here it has 0, right? It has how many bits here, right? So 0 1 1 0, right? And the 2 to the I minus 1 will give the max bits, right? We give the max bits, which is in this case here. We'll give I bits, right? So what is this? So because this is 2 to the I minus 1, this will give I bit, which is 3. This is because minus 1, right? So this 2 that between these, we're gonna be 2. Okay. So maybe between 2 to the I and 2 to the I minus 1, right? Will be the bit will always be what's that? I minus 1. Yeah, it will be I minus 1, right? Right, so let's do a couple more. So okay, so between these 2 0 and okay, this is the base case. The base case is 0 1 2. So 3 is equal to so let's say here 3 is between 2 to the 1 and 2 to the 2, so 1 bit. So it will be 2 to the I minus 1. This will be okay, so this is 2 because it's 2 to the I minus 1. So it's gonna be this bit 2 bit. Yeah, so 2 bit because it's 2 to the I minus 1. Okay, so between these this is always gonna be 2, right? This is 2 to the 3 minus, yes. This is 2 because it's between. So basically these keep 2 to 2 and everything else after that is always 2 bit. 2 until 2 to the 3 minus 1, right? That's my hypothesis. So now okay, so now we have 9, and so the 2 to the 4th is 16, right? 11, 12, 16, right? So this is gonna be what? So this is 0 0 1 0 0, right? 0 1 1 0 no 1 this right? 1 0 1. So is this hypothesis correct? Right? 1 1 110, and then finally so this one is we have 2, one have 2, one have 3, this one have 2 again. Oh my god, that is wrong. Okay, and then this is 4 because 2. Oh wait, this is 15, sorry. But also this is 2 to the 4th minus 1, right? So we said got back here, we got back to 1. Because it is 2, 2, 4. Right, so what do we see this pattern here? 2, 2, 3, 2, 3, 3, 4. Wow. Wait, 1, 0, 1, 1, 1, 1. Right, so the pattern seems like this. We have 3 bits. The number of set bit will be 1. Follow some pattern. So it seems like we go back here. 1, 10, 11, 1, 10, 11, 100. Right, 1, 10, 11, 100, 101, 10, right? So basically it's going through all these bits. Okay, so basically if we separate them, right, so this is basically the result of 1 above plus the 2 to the result of 2 to the 8, right? To the 3, which is 1. So this is 2, right? And then this is 1 here, right? Right, so this 1 from 1, right? So this is from 2 plus 2 to the 3rd, right? This give us, so from 2 we give 1. This is 1 from 2, right? We should give 2 here, and the result is 1 here. This is 2. So as we go here, it seems like the pattern go at the bigger scale here, right? So here we got 2 simply because also 2 to the 3 is 1 here. So this is the result of 3, right? The result of 3 is we got 2, right? And then this is the result of 4, which is 1 plus 2 to the 3rd, right? 1, 2, right? So we see the pattern here. We just have to somehow figure out this pattern here, right? Okay, let's see if I can make it. So this is basically, now we have 5, right? It is like 1, 2, 3, 4, 5, 6, 7 again. 5, 5 is 2, plus 2 to the 3rd, right? 1, so that's 3, good. So here's 6, 2, 6 is 2, right? Yeah. Plus 2 to the 3rd is 1. So this is 7. 7 is 3. Plus 2 to the 3rd, right? 1. So that's 4. finally we got that. This is simply, or simply, or this is simply 8, right? Which is 1. No, this is just special cases, right? So at the first glance, we need to figure out, okay, what is the place we are, right? So let's say I was given 14, right? How do we figure out what the third place is be, right? So it's gonna be so 14. First we gotta divide by 2, right? How do we figure out the gonna be 7? So first we gotta figure out like what 14 is gonna be equal, right? So 14 gonna be the maximum power of 2 it will be here is we can just loop from 0 to whatever, right? But maybe loop from 0 to, so basically find max power up to, okay. So for example 14 we get 2 to the 8, right? Is so it give us this bit right here, right? And because we give it that bit, we got this. So does that mean now we do 14 gonna be 8 plus 6, right? And the result of 8 is, we know that is the power of 3, right? So it's gonna be 1. And now we need to find 6. So 6, what is the max power of 2 we have? 2 to the 2, right? 2 to the 2 plus 3, right? So 2 to the 2, 4. That give us another 1. And then we find 3, right? 3 is gonna be 2 to the 2, 2 to the 1. 2 to the 1, which is another 1 here, plus 1, right? And of course 1 is only 1, right? So that gives us 3 bit. Yeah, I think that should work. So all that we do, right? So all we have left is, how do we find the max power up to less than any particular number? Okay, so is there a way to do that without us having to loop to find them? Right? But regardless, let's do, for now, let's figure out let's write a function power up to less than, we pass a number, we start with 2 to the 0. What's that? We for sure need some cash here for later. So we start with 4i in range of n, right? Okay, we can do this. I equals 0, y 2 to the I is less than or equal to n, less than n, right? So I plus equal 1, right? Like that. And then this would return us I, right? So for a particular number, they want us to loop from I to n. For I in range of n, right? So we need to put in the result. Right? Then, oh sorry, it's an array. Return result, right? So to calculate I, we need to figure out we need to break them into power of 2 plus something, right? Okay, so 2, okay. So let's try a recursive function, right? F of set bit and then number gonna be returning to, so basically we just send this result dot and set bit of I, right? Okay, if I equals 0, then return 0. Okay, the first thing we do is if n in the cache, and we return cache n without even looking, right? And then okay, so we also put it in the cache here, cache up and equal 0. And if n equal to 1, so 2 to 0 is 1, right? So okay, so now we need to first find the power of 2 less than n, right? So less than or equal to n. So this is gonna be set bit of power of 2 less than n less than, okay, so p2 equal to this, right? So this gonna be, the result of this gonna be 1, right? Because power of less than 1, it's gonna call, it's gonna be become this give us the number a bit oh, this just give us, oh, return 2 to the I, sorry, give us a power of 2, So power 2. We want to call set bit on the next one, right? So which is n minus p2, right? And let's start with 0, right? So set bit 0 will be count, right? So that means we're gonna call set bit on, n minus power of 2 less than the n here, and this will be count plus 1, right? Like that. Yeah. So for example, if we pass 14 here, power up to less than n is gonna give us 8. So 14 minus 8 is 6, and we increment by 1. And then when we use 6, power up to gonna give us another one here, 1 here, and then we have 3, so that's 2 bit, 2 set bit, and then 3 gonna be 2 to the 1, so that's gonna be okay. Sorry, right? So 14 we supposed to see 3 bit, right? So now 1, the 2 to 0, right? 2 to the 0, 2 to 0, right? I think that might be it, but let me check one thing real quick. So 1, 2, 3. So 2 to the 1, if it is 1, so if we go to 3, you got 2 bit, 3 you got 1 and 1, yeah. And then wait, hold on, 8, 6, 6. This is correct. It said extra 1 here. Okay. Right, so 14 gonna be 2 to the 3rd, good. We got that bit. Plus 6. 6 is 2. 6 is 1. 3. Okay, so 16, 14 here. 6 here is 2. Somehow we count extra. So should we pass negative 1 here? Let's see. And once we see the result, answer equals to this. If the answer is not in cache, then we cache them. I. Oh, if I not in, then yeah. Try this. What? Infinite loop? What? Infinite loop somewhere. Oh, right here. If n go 1, right? Then cache n is 1 bit. Turn 1. Turn cache in. What? It's still infinite loop somewhere. Oh, wait. If n in cache, then yeah. If n... Oh, return count, right? If n is 1, return 0 here. Return count. Or what's wrong with this? Is it infinite loop here? Y 2 to 0 less than n, yeah. And then 2 to 2, 2 to the 3, 2 to 4, right? We pass a number. We'll have to can we debug? Oh my god, it's the premium feature. Okay, fine. Let me debug this in my VS Code. Where did we do wrong? What is it? Counting bits. So let me return. No, print. If we pass 0, does it even infinite loop? What? Oh, 1, 2. What? So let's print this. See, we're looking correctly. Looking at in account. Looking at we have 0 and 1. Oh. Let's start at 0. So this is 0, we return 0. 1, right? Okay. So now 3, what happened? Oh. Why is it looking at? Oh. I 0, 1. So n plus 1, right? Whoa, whoa, whoa. Oh, we have some negative number. What? Looking at 3. What? Maybe it's better. Oh, we should just do ship then. Let's talk about this. Something odd here. Python interpret them. Right. I see. So let's do bit ship, right? So start at 1. I. So we ship one character to the left, it's equal to 2 to that character, right? Okay, so I equals 0, equal 1, y, I, and then I just gonna do ship by 1, right? Like that. What's wrong here? Oh. What? Same? Let me take a look. Hold on. Python let ship negative number. What is that? Why does it extend the? I don't want to interpret the negative, right? Python left. What is this? Let's print the I here. Print the I here. Hello. Oh, we have to return 2 to the I, right? No, but I right now looking at looking at 3, right? If we want to see 2 plus 1. Hey, so what's going on? So finally print I here. Why does it become negative? Or maybe we need to do the I before this, right? Right. Final. Oh, we out of the buffer. Right, so maybe lock them out to lock. Okay, looking at 3 here. 1, 2. Okay, final is wrong here, right? So basically, we start at 0 then. And we infinite loop. Hello. No, we have to start at 1. Because otherwise we shift a bit. So maybe we return out here mean that it is greater than or equal, right? So let's do some tests here. Let's put this function out here and do some tests. See if it's correct. Okay, so let's do power 2 less than 3. What do we have? What? Oh. Ah. So we want the one before that, right? So why this one less than good? 2 less than 3 good, and we shift and we become 4. So we need to do is we need to shift back. So what about equal? Right, so we shift left, shift back 1, right? So yeah, we got 2. So let's do some assert. 2 equal this, right? Good. And we do 4, right? It's also 2. No, become 8. What? So this way. Yeah. So let's say we do 5, also 2, right? So now we do 8 and 7 is also do that. So this is 3, right? Oh, what does 5 return? What? This, right? Oh my god. What? Hold on. If we pass to, is it pass here? No, it go all the way to 4. Wanna go? It go to all the way to. Let's just save the last one, okay? Let's do PII, right? Return PI. easier. So pi equal I. Okay. So we also want equal is fine. Okay. That. Oh, this is 2. What? 4 is wrong now? Become 8. Maybe this is wrong. Okay. This also become 8. What the hell was that? What? My friend's playing Fallout. Okay, I have. So 3 is 2 to the 1. 2 to the 1. Yeah. This is 2 to the 1 as well. No. 2 to the 2, right? Power of 2. That's gonna be. Wait a minute. Maybe I have it correct. So 4 here gonna be 4, right? Right. So this gonna be 4. This is 3, correct? This is 2. Right? 9. It's 4 right here. Final is I. Let's not forget about pi for now. I think I was assumption is wrong. So out here mean I is greater than or equal to n. Right, so if it is equal, we also equals fine. Right, so we out here we ship back. Is correct. Okay, so the last one failing here is becomes 16. What did I do wrong? Choose the 3, right? Oh. Okay. We want to also equal, right? So final here. We don't want hello here. Power up, you passing n, give me what? Let's put this into okay. Forward 3, pass 3, final 4. Outlook then it return 2, good. 4, good. 4. The out loop is 16, return 8, right? Oh yeah. This is 8. This is we want 7. 7, we want 4, right? Yeah. So this is the function. Good. Kind of good. Okay, run this. Let's see. Oh, it is end this one. 0. Okay. So it's just cache up and 0. Okay. And count. Wait, so base case is that. And just cache them outside, right? You cache them here. It's just not cache here. Right? But we still need cache because we cache them from the way to the end, right? Just here. Yeah, return. Oh, did we just return count? Okay. 0, guys. What is wrong here? So let's just do some printing. We asking for nothing with right. It's like this whole world keeps on messing it up. This. And then we have the answer. I'm thinking back to when you were in the sweater that you got from me. And in here we go. Looking up and we got the count. Okay. Go from 0, right? Okay. 0. Okay, looking at 1. This 1. Oh. Hold on. If they pass me this and I return 1. Okay, 0, right? So this is actually 1 plus, right? Let's not think about, let's not pass the count here. It's just gonna be like that. this is correct. 5 gonna be looking at what? 2, looking at 2, looking at 3, looking at 1. Good. Okay, so if we see in cash already, say in cash, five should see couple in cash. Okay, 1 is in cash. At 5 looking at 1. 5 is what? 5 is 2 to the 4 plus 1, right? So 1 is actually in cash. So let's do just say do like 16 so that we can see the 14 is what we need to see. So the 14 will see 4 in cash, 3 in cash. The 14 in cash 2. Okay, I guess let's submit and see if we time out. Oh no. No, we do not. Okay, so that is DP easy. Oh my god. Ugh. Okay, so is there a way for us to not have to loop this? Because maybe that was the most, that's where we spend the most time. So one thing we learn is any number can be 2 to the I created power with this power less than 2 or less than n power up to, right, plus n 3 minus and we cast them, right? So I feel like there should be a set bit counter version that, so this is just, this version has stack winding, right? We need to do recursion, tell recursion, right? But this version is not tell recursive optimize, right? So yeah, we should pass this. Will that be faster? So first, can we do tail recursion? And second thing is there a way to find greatest power to without looping, right? Because right now, right, anything that is not in cache, we technically just loop to here, right? From a particular 14 here, right? Can we just find that out by 14 divided by 2, right? So no, we have to keep divided by 2, right? That will figure out that's similar to the for loop. And if somehow we can chop off this bit, that'd be great. But for now, let's see if we can do a set bit with tail recursion, right? Which is we have to do set bit tail. What is it? Tail recursion, right? Tail, that means we need to add a counter here, right? Count, right? So which is the version we have earlier? Right, so let's do a tail here. We actually pass 0 here. Yeah, okay. So this will actually return the count. This actually be this one. And count plus 1, right? Oh. Now we have it wrong. Why is it not okay, so what did we do wrong with this set bit recursion here? It's all 0 now, right? N minus power 2 less than, yeah, and this count gonna increase by 1, right? Let's see, let's do a print here. Okay, by the way, also let's copy this link out so that we can put on the daily. Copy link. Okay, we run this. Oh, we need to also turn on this. Okay, so we're looking at, okay, fine. looking at 1. So if it is 0, return this. We get to 1, we return 0. Okay. It should be whatever count is, right? So when it go to 1 here, what is this nonsense? Looking at 2, okay, counts out as 0. 2, we figure out the power of 2 is 0, right? Looking at 0, when we see 0, yeah, count 1, right? So why is it 0? Looking at 0 and now 0, return this. Should be 1, right? Nothing bit up 2. Is it do the caching stuff? Okay, in cache right here. Okay, so we say we're looking at 0. So 2 gonna be okay, so 0 here, okay. Counting bit of 0, okay, 0, okay, good. 0, 0. Okay. So it's already in cache. So return count plus cache n. Right? That's the one. That is the one. Wait. Something is wrong here. Cutting bit. So it is 1 here. To 0. To 1. Right. We look at the time of the notification. Okay. Right. Okay. What did we do wrong? Okay. To 0, so it got here. It returned this. And so we can technically can cache it. Return cache n. Oh right, no, return count. Wait, no, we go down. Okay, hold on. Let it return count first. when we get here, that could also mean we reduce this is basically top down. So okay, so looking at 1, the count is 0, right? So whatever this is gonna be count plus 1, right? I think. Yeah. So does it have cache? Yes, too. Yep, it does. So I think this is the tail recursion of this. Okay. So right now we're seeing 55 millisecond, 1571 memory, whatever. I don't think it make any difference, but we will see, because maybe the compiler optimize this to become this or whatever, right? Submit this. It make no differences. Make no differences. What did these people do? 1 millisecond. Wow. Count plus 1. I don't know. I'm okay with this. Let me see. Let me ask Gemini, because I'm out of idea here. How do we find the greatest power of 2 less and then without looping? Oh, bit manipulation. What? Oh, subtracting 1. What is B in CPU instruction? But I still need to loop, right? Greatest power of 2 less than n without looping. I don't think it's possible, right? What? Look, Gemini, did you steal this stuff? Look, guys. What is this? Is this stealing? I don't know what is. Does Gemini steal stuff? It is very similar to... Wow. Bruh. So I don't know. Maybe that guy, 2013, right? It's not even in. It's not even in Have AI yet, right? Okay. Yeah, I don't know. How can we get to here? But I'm fine with this. Uh, yeah, it just take a long time. Like you figure out this pattern, then yeah, you can cache stuff, right? So I feel like that's what I feel about dynamic programming. You figure out the overlapping, and then you cache the right stuff, and that would do it, right? Okay. Convert the Java code to Python. Okay, let's try this. This is full implementation. Try this. Okay, submit. Wow, we improved by half. Very nice. Okay. We resort to use doc mathlog, and we improve by what? By half. Which is this one. Okay. Memory is a little bit more, maybe. I'll take that. Good enough for me. I'm thinking I'm gonna have to go cook now. Then I go play game with friends. Then I coming. Actually, and then I'll. And then I'll be back later nighttime do a couple more, but let's commit this to GitHub. Commit to GitHub, guys. So basically we have two solutions. Right. So I'm typing import list. So let's do import math. Right, so tail recursion is about the same. So let's do count bits. Recursive. Okay. And then we also have which is this part right here. So just everything here. So the first thing we did is we do this, right? And then we call set bit. Call set bit. Okay. And then we have count bits. Yeah, how many did we do? No difference at all. So then we do now bit recursive tail. In this we have basically everything here. Except we have self bit tail here. Bit tail, yeah. And we call this, there you go. So there's virtually no difference between the thing. And then finally this is the version we use. Yeah. Okay. So option is okay, so description. It is very easy to come up with solution runtime of on log n. Can you do it in linear time? What do you mean? Oh, I did not see that at all. But we'll have to come back to this to answer this question, because I need to commit this to the GitHub first. Uh, oh, runtime. Sorry. Oh, this is actually in the node. No different. Same as tail recursion. Oh, oh, oh. And finally our runtime improved by twice. Yeah. Okay, let's commit this. All right. I think we'll have to look at. Okay, we have to look at. Okay, this shifting negative there. Shifting. Oh, we did put that right. It's very easy to come up with a solution as ON login. Okay, so basically they're saying this, right? We find the power through, right? Can you do it in linear time and possibly in a single pass? Oh, we can eat the result of this to cache, right? So instead of We'll try that out. But come back.